Okay, Assalamualaikum and very good afternoon. So the participant is around currently 40 students out of I think 60. So 20 is still 19 is still missing, but I maybe they have problem with their internet and so on. But it's okay. So today we will finish on this hydroelectric station. Okay. So next week we will go on the second part of this chapter, which is the transmission line. Okay. So for this class, I only concentrated on the coal thermal. Okay, the thermal power station, which is we have covered in the previous class, and today we will cover on the hydroelectric station. Okay, why I cover only these two? Because these two type of power generation has been almost the technology is almost saturated and steady. Okay, in a steady state, there's no research is going on. So actually, the research on whether the on meaning that the research on the system is already saturated. Okay, so all the theory, the calculation is almost all is actually standard. Okay, contrary to the current energy such as fuel cell, solar panels, wind energy, and so on, the research is still going on. Okay, and so that's why I will not cover deeply on these two and these current technologies. Okay, but that one will be your assignment actually. Okay, so I will explain later. Okay, so without further ado, we go on the hydroelectric station. So as you can see here, and also please watch the YouTube video on the animation on this what I call hydroelectric, so that you have what I call you can visualize what is actually the system is actually inside this hydroelectric station. Okay, so this is actually the components inside the hydroelectric station where we have the reservoir, which is your dam, okay, and then your water will flow through the penstock here, and then this power station is where you install your turbine, your generator here, okay. So the flow of the water will actually rotate the turbine and it will generate the electrical power. Okay, and then the channel here we call penstock. Okay, this is the valve where we control the velocity of the water, and this is the surge tank. So the surge tank is actually used for protection. Okay, maybe there is what I call high pressure from the dam. So this will take the pressure, okay, the extra pressure to protect the generator here. Okay, so this is just the theory. I think most of you know about the hydroelectric where a dam is constructed across a river or also a lake to form a reservoir. Okay, and the energy from the water in the reservoir depends on the volume and the different height between the water source and the output, which is this one. Okay, so this is the water level and then this is the output. So the energy is depends on the water volume and also the what you call the different height between the generator here. Okay, and the head difference is called head. Okay, so the difference is actually called head, and the energy stored is directly proportional to the water head. Okay, meaning that the energy contained in the hydroelectric water dam is actually depends proportionally to the difference of the head. So actually the turbine, as you can see, the turbine convert the hydroelectric energy from water into mechanical energy, which is then transferred to the generator shaft for subsequent conversion to electrical energy. So this is actually the generator. So by comparison with the human size, as you can see, this is human. So the size is big, very, very big. Okay. As you can see, the water flow come from the dam will actually uh, rotate the turbine here, and this turbine is actually connected to the generator shaft. So when there is a rotation, so there will be a flux generated here, and the flux linkage will generate current and also voltage, and consequently will produce electricity energy. So the turbine has several types. Okay, the first what we call the impulse turbine. So it use a nozzle here, okay, where this nozzle is used to make the water pressure, okay, and spread into the turbine here. So the velocity of the water jet drive the wheels. Okay, so the wheels uses we call what we call a Pelton wheel. Okay, so this type of impulse turbine is mostly used for high water head. Okay, the second is actually the reaction turbine, and it is used for low and medium water head. Okay, example of the turbine here is what we call the Francis and Kaplan turbine. Okay, and this is what we call the Francis. The A is a Francis and B is Kaplan. Okay, as you can see, there is a difference between Pelton, where the position where the turbine is installed is different from the Pelton. The Pelton is actually installed like this, while for the reaction turbine under Francis and Kaplan turbine, so it is installed like this, horizontal. Okay, so the water will be directly flow inside this turbine and we will generate electricity. So enough on the theory. So we will go and concentrate on the calculations on the performance of hydroelectric station. Okay, so it's quite different from the coal combustion, which the coal the thermal, where the calculation, the units used is different. Okay, so please be noted that for the coal, the energy is in calorie. Okay, because we are actually heating the coal, so we use a calorie to represent the energy from the coal. Okay, while for the hydroelectric station, the energy is actually in unit omega second. Okay, sorry, not omega, watt seconds. Okay, where watt second is actually equal to joule. So if you uh, noted that 1 watt is actually equal to 1 joule per second. So 1 joule is equal to actually 1 watt second. Okay. So to get the energy stored inside the water, what you need to do is actually to multiply the water weight in Newton, multiply with the head. Okay, the head difference. So you will obtain the energy which is in watt second. So what is the water weight? So water weight is actually just multiplication of the volume of the water, multiply the density of the water and gravity constant. Okay. So in this point here, as you can see, it is known that for one, you should know that 1 meters cubic is has what we call 1,000 kilogram. Okay, the mass for 1 meter cubic of water is 1,000 kilogram. Okay, so meaning that the density here is 1,000 kilogram per meter cubic. This is the density. Okay, so the volume multiply with the density and multiply with the gravity constant. And the gravity constant is always 9.81. Okay, so density is almost fixed, which is 1,000 kilogram per meter cubic, and the gravity constant is also fixed, 9.81. The only variable is the volume of the water. Okay, so the energy stored is actually you need to multiply the water weight multiply with the head difference. Okay, let's look on the first example. A hydroelectric station has a reservoir with water volume of 5,000 power of 10 meter cubic and the head difference is 200 meter. So calculate electrical energy available if the overall efficiency is 75%. So what you need to do is to get the energy inside the water. Okay, where it's actually just a weight of the water multiply with the head. So right now the head is been given, which is 200 meter, but the weight is not given. Okay, so you need to calculate the weight of the water. The weight of the water is actually uh, multiply the actually the result of the multiplication of the volume. Volume of the water is given. So 5 multiplies 5 power of 6, sorry, 6 multiply with the density of the water, which is fixed 1,000, and multiply with the gravity 9.81. So this one will give you 4.91 power of 10 Newton. Okay, so the weight of the water 4.91 multiply with 20 meter. So you will receive your energy inside the water is 9.82 power of 12 joule or watt second. Okay, so inside the water. Okay, but when it is actually convert into electrical, so this is the water. So this is the turbine. Okay, so the turbine has an efficiency of 0.75. So the electrical energy produced, okay, energy produced is 0.75 multiplied with the energy, sorry, the energy from the water, which is 9.82 power of 12 watt second. Okay, so this will give you the answer of 0.75 multiplied with 9.82 power of 12. Okay, so 7.365 power of 12 with the unit of watt second. Okay, but since usually for electrical energy we are always referring in terms of in the units of kilowatt hour, so we need to convert this unit watt second into kilowatt hour. Okay, so the conversion, so 7.365 multiply of 12, you need to convert, so you need to divide by 1000. Okay, 1000, because we want to use kilowatt. Okay, so this is watt, so you need to divide by 1000, and then for 1 hour we have 3600 seconds. Okay, so you will actually get the answer by 1000 and divide by 3600, you will receive this answer, which is 2.05 power of 6 kilowatt hour. Okay, so we have the energy here, but oh my god, sorry, watt second, but since electrical energy is always referred in kilowatt hour, what you need to do is divide by 1000, okay, to convert into kilowatt, and then multiply also with the second, with the 3600 second, which is, this one is actually 1 hour. Okay, 60 minute multiply with 60 second. So you have actually 3600 second. That's why. Okay. And I hope it is clear. It's a very simple and straightforward actually. What you need to do, the first step is to calculate the weight. Okay. And then the energy. And then you have this answer. And then what you need to do to convert into kilowatt hour. Okay, so let's look on the second example. So I hope the noise from my this, ada orang potong rumput pula. Okay. The second example. Okay, thank you. Water from hydroelectric station is obtained from a 100-meter heat difference. Calculate electrical energy generated by 1 cubic meter flow, okay, of water every hour if hydraulic and electrical efficiencies are 0.86 and 0.92. Okay. So 1 cubic meter flow. So this is the volume. This is your volume. Okay. Because right now we want to see what is the energy inside that water. So what is the volume of the water? The volume of the water right now is 1 cubic. Okay, 1 meter cubic. And as you can see, we have two different efficiencies, which is the hydraulic and electrical efficiency. So same with the coal. Okay, so actually inside this hydroelectric, we have two subsystems, which is the water, the hydraulic, the energy inside the water, okay, and then the energy from the electrical generator itself. So all subsystems have their own efficiency. So 0.86 and 0.92. So the overall efficiency, okay, of the system is just multiplication of the efficiency of from the first subsystem multiply the efficiency of the second subsystem. Okay. So for the overall efficiency, so you just need to multiply the efficiency for all subsystems inside the system. So you will receive 0.679. So this is the overall efficiency. Okay. And then same again, you need to calculate the water weight first. So the water weight, the volume is 1 meters cubic, multiply with the water density, which is fixed 1000 kilogram per meter cubic, and the gravity. Okay, so the answer is 810 Newton. Then next is to calculate the energy inside the water. So energy inside the water is 98. Okay, the weight of the water multiply the head difference 100. So this one is around 981000. Okay, watt second. Okay, and then so this is the energy inside the water. So the efficiency, so the total energy output is actually you need to multiply with the efficiency. So you multiply with the efficiency. So the answer is actually 774990 watt second. Okay. Okay. Then 774990 watt second. So we want to convert into kilowatt hour. Okay. So what you need to do is actually to kilowatt. So multiply with divide by 1000, and then the hour is actually 3600 seconds. So you will receive the answer is 0.215 kilowatt hour. Okay, so this is the energy, the output from the water dam. Okay, so 0.215 kilowatt hour. But right now, the question one, what is the electrical energy for every hour? Meaning that you need to know what is the energy produced in 1 hour. So what you need to do is just because we want to cancel out this hour. So what you need to do is 0.215 kilowatt just multiply back with 3600 seconds. So you will actually receive the answer is around 774.99 kilowatt. Okay. Okay, so that is I think the second example. The third example is quite complicated, especially on the second question, but it's not really what I call very complicated actually, but you need to understand the question first. Okay, so a hydroelectric station has a catchment area of 2.4 square kilometer. Okay, and water capacity of 5 multiply with power of 6 cubic meter. The water head is 100 meter. The overall efficiency of the station is 72.6%. Obtain the total electrical energy that can be generated by the station. So I think the same thing again. So the energy from the water, which is the weight, you need to calculate the weight, multiply with the head. Okay, so the weight is actually the volume, which is this one, 5 power of 6, multiply with the density of the water, okay, multiply with the gravity, multiply with the height, which is 100 meter. Okay, so you will actually calculate this one. The answer you will actually receive okay, 4.9 watt second. Okay, so this is energy from the water, but the electrical output, you need to multiply with the efficiency of the system. 0.726 multiply 4.905 watt second. So this one is 3.56. 3.56 power of 12 watt second. Okay, or in kilowatt hour, what you need to do is 3.56, okay, divided by 1000 and 3600 seconds. So you will actually get around okay 989.2 kilowatt hour. Okay, so that is the energy, electrical energy output from the water. So the water, the energy contained inside the water is 4.9 power of 12 watt second, but due to the efficiency, which is the efficiency is not 100%, so the only energy water that can be converted into electrical energy is only 72.6%. So from that, we will receive only 3.56 power of 12 watt second instead of 4.9. Okay, because of the efficiency effect. Then you convert into kilowatt hour. So the kilowatt hour unit is 989.2. In the question, usually, we need for electrical energy, we always refer kilowatt hour. So I think the final answer should be in kilowatt hour. Okay. So actually, or watt second is actually refer to the energy from the water. Okay. Same thing with the coal, with the thermal. So when we refer energy that come from the thermal, we always refer using calorie. Okay, calorie. But for after the conversion into electrical, we need what is the unit in electrical energy? In electrical energy is kilowatt hour. So after the efficiency, you multiply with the efficiency of the system, you need to convert into kilowatt hour. Okay, because usually the electrical power engineer, they only know kilowatt hour. Okay, they are more appreciate if the unit is come with the kilowatt hour. Okay, so please refer back to the thermal coal, where as you can see when all calculation involved in the coal calculation, so all the units are in calorie. But after when it convert into electrical output, so it need to convert in kilowatt hour, because we know that 1 kilowatt hour is equivalent to 860 calorie. Okay, so this is actually from the coal. Okay. Next is on the second question. What is the drop of water if electrical load of 15 megawatt has to be supplied for 3 hours. So meaning that the water dam will actually drop, okay, because there is an energy load requires 15 megawatt for 3 hours. So there will be a drop of water because the water need to be flow down through the pipe. Okay, so there will be a drop of the level. So the question one, what is the drop level here? So actually, the drop level is actually related to the volume. Actually, the volume used uh, to uh, to supply 15 megawatt hour, which is 15,000 kilowatt hour actually. Okay, what is the volume? Okay, so we know that the dam, we have the catchment area. So this is the surface. Okay, so the surface is 2.4 square kilometer, and then this is the level. Okay, so this is kilometer square. Okay, so this is a meter. So the volume, as you see, is actually meter cubic. So you need volume is actually the surface multiply with the height here. So to get the volume, right? So actually the drop is actually related to the how many volume of water is used. Okay. So this is the actually the volume. Okay. But since this is used for 3 hours, so you need to divide by 3 multiply with 366 second. Okay. So the catchment area is 2.4 kilometer square, which is 2.4 multiply with 6 meter square. Okay. So that's why we have 2.4 power of 10. Multiply with the depth, which is represented by P. So P is actually the depth of the water, which is the level. Okay, so you will got the answer is around 222 P meters cubic. So this is the volume. This is the volume used to supply 15 megawatt power. Okay, so this is only the what you call the complicated one. But after that, when you get the volume, so actually the other procedure is just a straightforward. Next is actually to get the weight of the release water. Okay, so the volume multiply with the constant, the density of the water, and then multiply with the gravity. So this is the weight of the water, 21.8 P multiplied 10 of 5 Newton. Okay, so the generated power, okay, so the output of electrical, okay, so you need to multiply with the efficiency 0.726 multiply with the energy from the water, which is 21.85 sorry, P here, multiply with the height difference, which is 100 meter. Okay, so you will receive this one, kilowatt. Okay, so this is the energy from the water. So this is P in, and this is your P load. Okay, sorry, not is this is energy. This is actually the it's okay, power in, and this is power load. And based on that, you will get your P, okay, because P in must equal to P load. So the level or the depth of the level of the water that reduce is around 9.47 centimeter. So meaning that to supply 15 megawatt load, the water level will reduce to 9. The reduction is around 9.47 centimeter. Okay. I think that's all. So this is the additional self-study question. I have already posted inside your WhatsApp group. So please refer to that for your own exercise. Okay. The solution is already also given. So please try. And this is about gas turbine power station. I think this one is not will not be covered. Okay. Also for the wind power. So actually, for your information, the test and final exam will only cover the first two power generator, which is the coal combustion, and then the second one is uh, the hydroelectric. Okay. So this one, wind power electrical generator, I think this one will be your um, assignment actually. So let's look on your assignment. Uh, I will share with you. Okay. Okay, I hope you can see in the display right now is your um, second assignment. Actually, this second assignment actually for this one, usually for normal class, what we want the student to do is actually to present before the class. Okay, we present in front of the class. Okay, but since we are not allowed to come into the campus, I think we just proceed with the online, but no presentation at all. What you need to do is to using online platform, which is the Koggle. Okay, the Koggle is actually a mind map. Okay, mind map where you can actually put the link, the videos, and so on, or from the other articles and so on. Just put it inside your mind map. Okay, so so the others can actually go through the video and so on. Okay, so the output of the task is a mind map of pre-selected source type of power generation using Koggle. Okay. For my class, please, because other class may be different, different approach and different subtopic. But for my class, you need to choose either three. So please form a group, the same group for the as you are actually will be conduct this assignment using the same group for the first assignment. Okay. Please choose either to do solar photovoltaic, which is this one is the conventional one lah. Okay, you use a solar panel to produce, okay, to produce electrical energy from the solar panel. Okay, and you can also choose wind energy, or the third one is the solar thermal. So solar thermal is quite new, but in Malaysia there is no implementation yet. But this solar thermal technology has been implemented in Spain, Europe side. What they do is actually by concentrating, use a mirror, and the light from the mirror is concentrated into a one what I call a tower. Okay, so actually all the mirror will actually heat up the tower, and from the heat it will actually rotate a turbine, okay, and will produce energy. I don't have a picture. I forgot to. Maybe you will actually Google on what you call the solar thermal. So this is not actually a thermal used for your water heater. Okay. Currently, maybe some of our home have their own solar panel. Actually, that solar panel which is installed at the rooftop, there are two purposes. The first one is to produce electricity, okay, under feed-in tariff, and there is a second installation of the rooftop solar. Is that one is actually just to heat up your water heater. Okay, so but this solar thermal is not uh, referring to that kind of installation. This solar thermal is quite big in terms of its capacity and in terms of its space use. Okay, so it's actually a very new technology. Okay, so you can either choose these three. Okay, and the content of the mind map should be include the diagram from online videos, YouTube, and so on. You can actually from YouTube you can actually take the link and then post inside your mind inside the Google. Okay, your online reading material maybe articles. So you just put the link inside that. Okay, and then summarize import and then the basic structure of your mind map should be at least have the background of that particular technology, the working principle of the system. For example, the solar photovoltaic is actually you know is produce DC voltage and DC current, but how it is used, how from the DC power it is can connected to a grid system. The grid is AC system. So how? So there is a system, the conversion system that involved. Okay, the conversion from DC to AC. So you can actually put that in the working principle of the system, or maybe how the solar is transferred, the irradiance of the sun is actually convert into DC voltage and DC current. Okay, and then the third point is the progress and the impact. What is the progress of the current solar photovoltaic technology right now, and what is the maybe the future for this for solar photovoltaic? Okay. Uh, The Google mind map can be converted into several types of files. Okay, but I didn't familiar with the files, whether it is can be actually convert into video. I don't know, but it can be converted into PDF. Okay, so I think you just convert into a suitable file that suit you and upload in the e-learning platform. Okay, so same with the Nali one. Okay, and so null itu one, so you need to submit. I will actually create a new submission link uh, in week 15 so that you can submit both assignment. Okay, I hope that one clear. Oh, there's a chat. Yes, yes, but you can deadline is I give you a freedom, okay, before week 15, but you can actually submit, you can actually complete it early. Okay, please arrange your time because we know that currently students are busy right now, you know, with the tests and also assignments. Okay, so I hope that one clear. So okay, so I think we finished our class for today, and please be noted, next class will be your transmission line. Okay. This video is recorded, so I will post after I have received the file, the video file. What should be introduced in background? Uh, Maybe on the uh, why we are going for solar, why we are going for renewable energy. This is actually renewable energy. So why we are going for wind energy, for example. Okay. Okay, and then maybe what is the first prototype for the wind energy system? Who is the first inventor and so on? Okay, and maybe where is the first installation and so on. It's up to you or your creativity on how to. This is just a guidance. You can put many things inside your Google. Okay, I think that's all. Thank you very much for your attention. So we dismiss the class. Okay, so thank you very much.